Hello, everyone. I'm Ramya. I'm a product lead with a nonprofit, Humanitarian OpenStreetMap Team, in short, HOT or HOTOSM. HOT is a US registered nonprofit which is focused on humanitarian response through open mapping solutions. This humanitarian response covers both disaster preparedness and disaster response situations. Areas that are subject to risks like flood or earthquake or cyclones, or those that are facing the risks. So in these areas, HOT tries to provide adequate, up-to-date map data or geodata, spatial data, so that the key decision makers, like the government or people who work on the field, like offer direct help to the people, they would make use of this map data to provide timely help for the people who are there in that particular situation. And all of this is made available through open mapping solution. The open mapping component here refers to OpenStreetMap, or OSM in short. OSM is an open source alternative to many proprietary mapping options. So it's called the Wikipedia of maps. Anybody would be able to sign up on OSM platform with your mail ID, and you'll be having a username. With that, after you sign up, you'll be able to add, modify, or delete any of the existing data. In this case, in case of OSM, the ownership stays with the community. So that is one of the key differentiation when compared to the proprietary softwares. So OSM is the bedrock of all that we do at HOT, be it the humanitarian response or any capacity building training programs that we offer, or the partnerships that we forge with other organizations. All that, everything is centered around OpenStreetMap, hence the name Humanitarian OpenStreetMap Team. Now, we also have our own tech team, which helps in building and maintaining several tools around the OSM ecosystem. And one such tool is the OpenStreetMap Galaxy. This was launched last year in April 2021. The aim for, or the vision for OSM Galaxy is to provide a single platform or a single website from where any user in the OSM community would be able to access all different kinds of data outputs, spatial data outputs. Now here, the data outputs or the data needs around the OSM community could be n number of things. There are number of possibilities. I'll just outline a few possibilities. One could be simply raw data exports or dumps that you could download from OSM. Say if you want to download all the building outlines in Bangalore, or the entire road network of India, or say the hospitals in Bangalore. All of that is called raw data output. And you should be able to do that with Galaxy. There are other kind of users who just want to access certain kind of statistics instead of accessing the feature itself. Maybe instead of downloading the outlines of buildings, you just want to know the kilometers of highways in India. Maybe all the roads that are named as EMG Road, Mahatma Gandhi Road. So such data, such filtering, that is also possible. So, these are just two different needs that I've presented here, but there are different other possibilities, different kinds of data outputs that is needed for the OpenStreetMap users, and that is also possible to access via OSM Galaxy. So through Galaxy, we are really ambitious about providing all kinds of OSM data outputs in one platform. Now, you might wonder if there are not tools already in the OSM ecosystem offering such solutions. Of course they are. There are several tools. These tools are very specific in the OSM context, so I don't want to touch upon each of these tools, but just outlining a few here. So through Galaxy, we want to reduce the dependency on this multiple different platforms. Because for each of the tools, suppose you want to download raw data, the user might want to access Overpass, or it could be Planet or GeoFabric. And there is certain learning curve attached to each tool. It could be a query language, or simply going through the documentation, the API documentation, or the tool documentation to understand what's possible and what's not possible. Now, with Galaxy, we would want to reduce this dependency or overhead for the users so that they just access all of this data in one place without having much complexity. Now, going to the software components that make up Galaxy. this is a high-level overview. I'll talk about each of these components separately. So we want to build our own data source, which is called Underpass. People who are aware of OpenStreetMap, this name might ring a bell because Underpass is a wordplay around an existing tool called Overpass. And then we want to build our own backend, a Galaxy API that would help retrieve data from the Underpass data source. And finally, a website to present all of this data to the end user in an easily understandable way. Starting with the Underpass data source. OpenStreetMap makes available minutely and hourly files through which you can access all the changes that has been done to OpenStreetMap. So in Underpass, we are consuming minutely files, minutely changes of all the features that are modified on OpenStreetMap. And this is done using a C++ script. And the processing script updates 3 different data stores at the end of it. One would be a data store containing all the raw data from OpenStreetMap. Second would be statistics computation on this raw data. And the statistics is already grouped by specific user. So if I have an account on OSM, the script would have some statistics for my username. Say like Ramya has contributed so many number of buildings in Bangalore and so many kilometers of highway all over the world on OSM and so on. And there is also like one key aspect in OSM, which is around data quality. So all the data that goes into OSM has to be validated. And through Underpass, we are trying to capture these data quality issues as well. So one script, and it captures data in 3 different data stores. One is the raw data, the other is the statistics, finally the data quality or the validation table. Now that the data source is there, then we have to build an API to access all of this for end users. Now that's done using the Galaxy API, and nothing much to say here. Here we just have one data source, which is Underpass. Plan is to include more other relevant data sources for the OSM community and make the Galaxy API talk to each of the data stores. Galaxy API is written in FAST API framework. And finally, there is a Galaxy website. So Galaxy website talks to API, which in turn talks to the Underpass data source and presents the data for end users. Now, we have a minimally functioning Galaxy website, which is more like a proof of concept, which provides access to Mapathon Statistics. So within OpenStreetMap, there is this concept called Mapathons, where people organize, bring together a group of bunch of people, usually like this is remote, bring together a bunch of people, and they contribute data to a specific cause or to a specific region. So at the end of Mapathons, people would definitely want a leaderboard to understand the contribution they have made for that particular impact. So for that, the key one would be leaderboard. So we call it as a Mapathon leaderboard statistics. Right now, that feature is available on the Galaxy website. So it's still not production ready. I would call it as a beta release for this particular feature. Overall, the Galaxy itself is a work in progress. I had a nice GIF here, but this is converted to PDF, so it doesn't show up good. There are still like other statistics and other aspects within the data source and the API and the website that the team is continuously working on. Quick status check on each of it. Underpass, with Underpass, we are already storing the entire raw data from OpenStreetMap in one data store. We are also computing statistics for Mapathon, users, countries, and there were like a few technical aspects that the team has been working on in the past few months, which is around multi-threading and IAC setup and all of it. All of the code for each of the software components is available under GitHub. So I'm also providing a link to each of it here. So you will be able to access it under HOTOSM organization. And then the Galaxy API, which is in FAST API framework. With the Galaxy API, we are also offering a Python package and a Node.js package, which can be directly used by anyone who wants to have their own front end or build their own representations around OpenStreetMap data. Finally, the website, for now, the website just has the Mapathon summary statistics and a brief of user statistics. And the login here is tied up with OpenStreetMap because per GDPR regulations on the OpenStreetMap project, the data would be accessible only for authenticated users. So all the sign-ins are tied up with OpenStreetMap logins there. Now, we definitely need help on this project. So there are different ways anyone who is interested could contribute to OSM Galaxy. On the code development side, it could be on the front end, back end, like the code improvements, feature implementations, all of it. On the design aspect, we need help on wireframes, doing user interviews and research. Documentation, technical documentation on GitHub and also around the API explaining like how each endpoint works. On the testing aspect, testing the output itself from the Galaxy API or the raw data exports. On the data side, we need help from someone who could help analyze this large gold mine of data that we're sitting on, which is this OpenStreetMap data, and identify use cases that could be presented using the Galaxy website. Yeah, we also hold working group meeting every month. So working group meeting is a space where the hot tech team interacts with the rest of the community and presents monthly update of the progress we have been making. So every month we meet with the community. And if anyone is interested in contributing to Galaxy project, you can register your interest in the given link. It's a bit.ly link. And you can also write to tech@hotosm.org. We are also planning to float a couple of projects via Outreach and GSOC in the coming round. I think the December to October round. You can like catch me for like any questions around these internships projects as well. Yeah, any questions? Yeah.
How is the data validation happening?
So for now, we are only capturing geometry-related issues from OpenStreetMap. So there are different kinds of validation we can do against the OSM data. It could be the tag completeness. Each feature in OpenStreetMap is identified through a unique combination of tags, key-value pair. A building is identified, building equals yes. It cannot be, you shouldn't mark it as building equals no. Then that's a wrong tag combination. So those errors which can be easily captured by computers, right? The tag combination, or it could be the geometry errors. So there is the highways have to follow us, linear features have to follow a certain angle. A road cannot like bend at a certain angle. If that geometry, the line there on the database bends over a certain angle, then that is captured as a validation issue. So on and so forth. So there are like many different ways in which we could capture this. Very like that could be captured easily by the script. We are capturing only those for now. Mostly around the geometry of buildings, geometry of highways, and duplicate buildings when there are like two features overlaying in the same areas. Very minimal ones. That's how we are doing it with the Underpass script. Okay, thanks everyone. Thanks for your time.